Section 9 of Familiar Letters on Chemistry. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by M.L. Cohen, Cleveland, Ohio, March 2007. Familiar Letters on Chemistry, Letter 9. My dear Sir, the facts detailed in my last letter will satisfy you as to the manner in which the increase of mass in an animal, that is, its growth, is accomplished. We still have to consider a most important question, namely, the function performed in the animal system by substances destitute of nitrogen, such as sugar, starch, gum, pectin, etc. The most extensive class of animals, the graminivora, cannot live without these substances. Their food must contain a certain amount of one or more of them, and if these compounds are not supplied, death quickly ensues. This important inquiry extends also to the constituents of the food of carnivorous animals in the earliest periods of life, for this food also contains substances which are not necessary for their support in the adult state. The nutrition of the young of carnivora is obviously accomplished by means similar to those by which the graminivora are nourished. Their development is dependent on the supply of a fluid, which the body of the mother secretes in the shape of milk. Milk contains only one nitrogenized constituent, known under the name of casein. Besides this, its chief ingredients are butter (fat) and sugar of milk. The blood of the young animal, its muscular fiber, cellular tissue, nervous matter, and bones must have derived their origin from the nitrogenized constituent of milk, the casein, for butter and sugar of milk contain no nitrogen. Now, the analysis of casein has led to the result which, after the details I have given, can hardly excite your surprise, that this substance also is identical in composition with the chief constituents of blood, fibrin and albumin. Nay more, a comparison of its properties with those of vegetable casein has shown that these two substances are identical in all their properties, insomuch that certain plants, such as peas, beans, and lentils, are capable of producing the same substance which is formed from the blood of the mother, and employed in yielding the blood of the young animal. The young animal, therefore, receives in the form of casein, which is distinguished from fibrin and albumin by its greater solubility and by not coagulating when heated, the chief constituent of the mother's blood. To convert casein into blood no foreign substance is required, and in the conversion of the mother's blood into casein, no elements of the constituents of blood have been separated. When chemically examined, casein is found to contain a much larger proportion of the earth of bones than blood does, and that in a very soluble form, capable of reaching every part of the body. Thus, even in the earliest period of its life, the development of the organs in which vitality resides is, in the carnivorous animal, dependent on the supply of a substance, identical in organic composition with the chief constituents of its blood. What, then, is the use of the butter and the sugar of milk? How does it happen that these substances are indispensable to life? Butter and sugar of milk contain no fixed bases, no soda nor potash. Sugar of milk has a composition closely allied to that of the other kinds of sugar, of starch, and of gum. All of them contain carbon and the elements of water, the latter precisely in the proportion to form water. There is added, therefore, by means of these compounds, to the nitrogenized constituents of food, a certain amount of carbon, or, as in the case of butter, of carbon and hydrogen, that is, an excess of elements which cannot possibly be employed in the production of blood, because the nitrogenized substances contained in the food already contain exactly the amount of carbon which is required for the production of fibrin and albumin. In the adult carnivorous animal, which neither gains nor loses weight perceptibly from day to day, its nourishment, the waste of organized tissue, and its consumption of oxygen stand to each other in a well-defined and fixed relation. The carbon of the carbonic acid given off with that of the urine, the nitrogen of the urine, and the hydrogen given off as ammonia and water, these elements taken together must be exactly equal in the weight to the carbon, nitrogen, and hydrogen of the metamorphosed tissues, and since these last are exactly replaced by food, to carbon, nitrogen, and hydrogen of the food, Were this not the case, the weight of the animal could not possibly remain unchanged. But in the young of the carnivora, the weight does not remain unchanged. On the contrary, it increases from day to day by an appreciable quantity. This fact presupposes that the assimilative processes in the young animal is more energetic, more intense than the process of transformation in the existing tissues. If both processes were equally active, the weight of the body could not increase, and were the waste by transformation greater, the weight of the body would decrease. Now, the circulation of the young animal is not weaker, but, on the contrary, more rapid. The respirations are more frequent, and for equal bulks, the consumption of oxygen must be greater, rather than smaller, in the young than in the adult animal. But, since the metamorphosis of organized parts goes on more slowly, there would ensue a deficiency of those substances, the carbon and hydrogen which are adapted for a combination with oxygen, because, in the carnivora, nature has destined the new compounds, produced by the metamorphosis of organized parts, to furnish the necessary resistance to the action of the oxygen, and to produce animal heat. What is wanting for these purposes, an infinite wisdom has supplied to the young in its natural food. The carbon and hydrogen of butter, and the carbon of sugar of the milk, no part of either of which can yield blood, fiber, and albumin, are destined for the support of the respiratory processes, at an age when a greater resistance is opposed to the metamorphosis of existing organisms, or, in other words, to the production of compounds which, in the adult state, are produced in quantity amply sufficient for the purpose of respiration. The young animal receives the constituents of its blood in the casein of the milk. A metamorphosis of existing organs goes on, for bile and urine are secreted. The materials of the metamorphosed parts are given off in the form of urine, of carbonic acid, and of water, but the butter and sugar of milk also disappear. They cannot be detected in the feces. The butter and sugar of milk are given out in the form of carbonic acid and water, and their conversion into oxidized products furnishes the clearest proof that far more oxygen is absorbed than is required to convert the carbon and hydrogen of the metamorphosed tissues into carbonic acid and water. The change and metamorphosis of organized tissues going on in the vital processes in the young animal consequently yield, in a given time, much less carbon and hydrogen in the form adapted for the respiratory processes than correspond to the oxygen taken up in the lungs. The substance and of its organized parts would undergo a more rapid consumption, and would necessarily yield to the action of the oxygen, were not the deficiency of carbon and hydrogen supplied from another source. The continued increase of mass or growth, and the free and unimpeded development of the organs of the young animal, are dependent on the presence of foreign substances, which, in the nutritive process, have no other function than to protect the newly formed organs from the action of the oxygen. The elements of these substances unite with the oxygen; the organs themselves could not do so without being consumed; that is, growth or increase of mass in the body, the consumption of oxygen remaining the same, would be utterly impossible. The preceding considerations leave no doubt as to the purpose for which nature has added to the food of the young of carnivorous mammalia substance devoid of nitrogen, which their organism cannot employ for nutrition, strictly so called, that is, for the production of blood, substances which may be entirely dispensed with in the nourishment in the adult state. In the young of carnivorous birds, the want of all motion is an obvious cause of diminished waste in the organized parts; hence milk is not provided for them. The nutritive processes in the carnivora thus presents itself under two distinct forms, one of which we meet again in the graminivora. In the graminivorous animals, we observe that during their whole life their existence depends on a supply of substances having a composition identical with that of sugar of milk, or closely resembling it. Everything that they consume as food contains a certain quantity of starch, gum, or sugar, mixed with other matters. The function performed in the vital processes of the graminivora by these substances is indicated in a very clear and convincing manner, when we take into consideration the very small relative amount of the carbon which these animals consume in the nitrogenized constituents of their food, which bears no proportion whatever to the oxygen absorbed through the skin and lungs. A horse, for example, can be kept in perfectly good condition
if he obtains as food 15 pounds of hay and 4